In this video, I will be building a 2-inch bore air cannon. The design is quite simple, but the way in which it operates can be difficult to understand, so I have provided links in the video description that will make the function of the internal valve simpler to visualize. This type of air cannon is made in what is called a coaxial piston design. The barrel runs through the center of the chamber, and at the end of the barrel toward the back of the cannon is a free-floating piston. When pressurized with air, the piston seals the barrel closed, and air leaks around the sides into the front of the chamber. When the ball valve is opened in the back, pressure drops behind the piston, and the seal it has against the barrel is broken, allowing all the air in the front of the chamber to escape. This escaping air throws whatever projectile is loaded into the barrel at incredible speeds. I start this project with a 3-foot length of 3-inch diameter PVC as the chamber, and a length of 2-inch diameter PVC that is 3 feet and 2 inches long for the barrel. All pipe and fittings used in this project must be pressure rated. First, using PVC primer and a healthy coat of PVC cement on both the pipe and fitting, a threaded female adapter is pressed onto one end of the 3-inch pipe. Twisting the fitting a quarter turn quickly before the glue dries will ensure that there are no leaks later on. The second fitting used for this project is a 3-inch to 2-inch reducer, which is glued by the same process to one end of the 2-inch diameter barrel. Once the glue is firm enough to hold the barrel in place, the reducer is prepared with more primer to be cemented into a male threaded fitting, which can be screwed into the female fitting already on the chamber. As with the previous fittings and all following, plenty of primer and cement should be used on both surfaces, and they should be pressed together quickly before the glue has time to set. The barrel can now be threaded off the chamber and set aside for later. Turning to the far end of the chamber, which will be the back side of the cannon, a series of fittings will be attached beginning with a 3-inch coupling. Into this coupling will be glued a 3-inch to 1.5-inch reducer, and into that an even smaller reducer going from 1.5 inches down to a threaded 1/2-inch opening. This will make up the back of the cannon, but before gluing the assembly to the chamber, we need to insert a bumper to cushion the piston that will be inserted later from slamming into the hard plastic reducer when fired. The bumper I will be using is a 3-inch tank-to-bowl washer that is usually used for repairing toilets, and can be found in the plumbing section of most hardware stores. The washer should be placed inside the coupling so it sits flat against the reducer, and the whole thing can now be glued to the chamber where it belongs. The point of the reducers that have now been glued in place is to attach a 1/2-inch ball valve, which is done with a 2-inch long 1/2-inch PVC pipe nipple. Before threading it into the reducer, a hole needs to be drilled into the side to accept a brass air compressor tank valve. The hole drilled should be just smaller than the threads on the valve so that the threads bite into the plastic and hold it in place with an airtight seal. A little PVC cement will soften the plastic and help the valve to thread in easily. The nipple can now be screwed into the reducer using some TFE pipe thread paste for an airtight seal. With a little more thread paste on the other end, the 1/2-inch ball valve can now be attached to the end of the cannon, and the whole thing can be set aside to begin work on the piston. The piston will be made out of two 3-inch diameter gas vent T-caps, which can be found in the home ventilation aisle of most hardware stores. These caps are made out of galvanized steel and have a lip around the top rim that will need to be trimmed off so that they both look like the cap on the right. Grinding the lip off is easy work with a bench grinder, but if necessary, it could be done with a file. With the edges of both caps filed smooth, the inside of each is given a rough surface with a piece of sandpaper, as well as the bottom side of one of them. The cap that has only been roughed up on the inside is now filled with epoxy, and the second cap is pressed into it. There should be enough epoxy between them that any air is forced out. After about 20 minutes, the piston should be holding itself together. A large rubber washer or a 3-inch diameter circle cut out of a piece of sheet rubber is now glued onto the face of the piston using super glue. This rubber will be what creates an airtight seal against the face of the barrel. The last step in creating the piston will be to make it as form-fitting as possible inside of the 3-inch chamber. This is done with aluminum tape. It's essential for the function of the cannon that some air is able to leak around the piston, but even if it was made as tight a fit as possible, it's unlikely that the piston would totally block all air from passing by. For this reason, it's more important to get a very close fit than it is to worry about it sealing the chamber from pressurizing properly. With about 3 wraps of aluminum tape, my piston is finished and can be pushed into the chamber of the cannon with the rubber face directed toward the opening. All that remains now is to add some finishing touches to the barrel. The end that will be facing the piston must be very flat and sanded smooth for a perfect seal against the rubber. I also need to be sure that the barrel stays centered in the middle of the chamber and that anything loaded into it cannot fall all the way to the bottom and interfere with the piston. Both of these things are accomplished in one step. About 2 inches away from the end of the barrel, 4 self-tapping screws are drilled through the wall and adjusted so that they will keep the barrel centered in the chamber. On the inside of the barrel, the tips of these screws will prevent anything from being pushed so far in as to hit the piston, and so that problem is solved as well. This completes the cannon. After 24 hours to allow the PVC cement and epoxy to cure, the barrel can be inserted, and with some more TFE paste, it can be threaded tightly into the chamber. The cannon is now ready to test. Since the end of the barrel is rather dull, a short section of sharpened pipe can be used to cut slugs that will fit it. With a slug loaded, the chamber can be pressurized with 15 pumps from a bicycle pump, or 40 psi from an air compressor. Always keeping the barrel in a safe direction, when ready to fire, the ball valve is opened. If you enjoyed this video, please be sure to comment, subscribe, and share it on Facebook and Twitter. If you'd like to see more, click one of the following boxes or look up my channel, Nighthawk and Light, on YouTube. Thanks for watching.